Okay, so we are given a problem. We need to perform a dimensional analysis to establish the Sherwood, Reynolds, and Schmidt numbers as dimensionless groups, and this is based off the finding of an equation for the mass transfer, evaporative mass transfer of a fluid flowing down the sides of a cylindrical vessel. Alright, so first we need to establish the variables that we're going to use. First would be the mass transfer coefficient, which would be Kc, and then we're going to use the velocity of the fluid moving. Then we're going to have the density of the fluid and also the viscosity of the fluid. And then we're going to have the diffusivity from the fluid to the surrounding environment, and then we're going to have the diameter of the tube. Alright, and we're going to want to use the units to establish a dimensional matrix. So we're going to have kilograms, meters, and seconds. Alright, so for the first one, the mass transfer coefficient, kilograms in the pure, you have meters in the numerator and seconds in the denominator, so that's going to be -1. And velocity is the same, so we're just going to repeat that. Density is mass divided by volume, so it'd be 1 in the numerator and -3 for cubic meters in the denominator, and seconds isn't involved. And then so next we're going to move on to viscosity, which is kilograms divided by meters times seconds. So it'd be 1 divided and then -1 and then -1. For the diffusivity, kilograms aren't involved, and it is just square meters per second. So 2 and then -1. And then we just have the diameter of the tube, which is just meters. Alright, so now we need to determine how many dimensionless groups we need, how many pi groups we need. And to do that, we use this equation, I is equal to n minus r. I is the number of groups that you need, n is the number of variables that we have, which is 6, and r is the rank of the matrix. And so now we're going to move over to Google Colaboratory to find the rank of this matrix. So first we're going to import numpy as np, just as a shorthand. Then we're going to want to make our matrix, and so I'm just going to put m for matrix is equal to, and p dot, we're going to make an array. And to save a little bit of time, I just had it copied and pasted, but I need to tab it over. Alright, and then we're going to need to use NumPy's linear algebra to find the rank. So we're going to do np.linear algebra linalg dot matrix rank. We're going to find the rank of m, and the rank of our matrix is 3, so we're just going to minimize this. So r is equal to 3, so I is equal to 3. We need 3 pi groups, so it'll be pi 1, pi 2, and pi 3. And so we need to establish what variables we need to head off the groups, something that we can easily cancel out. So we're going to have Kc be 1, so pi 1 is just going to have Kc, and pi 2 is going to have the velocity because it has the same units as the mass transfer coefficient, so that'll just be easier. And then next we're going to do the viscosity. Okay, So, and you'll see later on why we chose velocity as our second group. It just makes things a lot easier, because we'll have to do less calculations, less math. All right, so for pi 1, we're going to have our remaining variables in this group. So we use mass transfer, velocity, and viscosity. So we're just going to have the density, the diffusivity, and the diameter. So we're going to have our density first, so we'll raise that to the A power. We'll have the diffusivity and raise it to the B power, and the diameter and raise that to the C power, all times the transfer coefficient. So now we need to do our analysis of the units. So for kilograms, let's see, we have density, which has 1, so it'll just be A. Diffusivity doesn't have kilograms, and neither does diameter, and neither does the mass transfer coefficient, so A is just equal to 0. Next, we're going to move on to our distance, our meters. And so we're going to start with our density. It has a -3A. Our diffusivity, which would be a +2B. And then we have our diameter, which is just +1, so B plus C. And our mass transfer coefficient is equal to 1, or the meters is equal to 1, so we'll just do +1 equals 0. We can already cancel out the A since we know it's 0, but we don't have enough information yet to figure out the rest of it. So we will move on to seconds and then do the same. So we don't have, density doesn't have seconds in its units, so we can just skip it. The diffusivity has in the denominator, so we'll just have a -B, and diameter doesn't have it, so we can ignore it. And then our mass transfer coefficient is has it in the denominator as well, so -1 equals 0. As we can see that B is equal to -1. So now we can put that in this equation up here. And so we'll add 2 to both sides and subtract 1 from both sides, and we can see that C is equal to -1 plus 2, which is equal to 1. So now we'll put it in our equation. Density is not included, and B is equal to -1, C is equal to 1, so we'll have the diameter divided by the diffusivity times the mass transfer coefficient. Okay, and so if you take notice here that the units for velocity and mass transfer coefficient are the same, so that means that the exponents for each variable in the equation would be the same. So we can just write it like this, since the exponents are equal, and the units of the mass transfer coefficient and velocity are equal. Therefore, all of these numbers will just be the same, and we can say that the equations would be identical. So now we're going to go to, now we're going to go to the third equation, as equal to, we're going to raise the density to the D power, the diffusivity to the E power, and the diameter to the F power, and we're going to multiply it by the viscosity. And we have to do it for the viscosity because the units are different. So let me highlight these so we don't lose them. All right, so we're gonna do our unit equations. So kilograms. Let's start with density. So it has a 1 in the numerator, so it's A, or not A, sorry, I was copying it from the top. It will be D. And then we'll move on to the diffusivity, which doesn't have it, and the diameter, which doesn't have it, but the viscosity does have it. It's a positive 1, so it equals 0. Looks like a 6. I will change that so it looks like a 0. And then we can easily do the math here and say that D is equal to -1. We'll go to the meters and start with the density, so minus 3D. Go to the diffusivity, positive 2E, and diameter, which is positive E, or F. And viscosity has it in the denominator, so it's -1 equals 0. We know what D is, but we don't know E or F, so we're just going to have to see if we can do a little more investigating after we do the last equation. So we'll go to seconds, and we'll see that density doesn't have it. The mass diffusivity does have it, so it'd be minus E. Diameter doesn't have it, but viscosity does, and it's -1. That'll be equal to 0. So we can see that E is also equal to -1. So now we can do the math here real fast. Let me just scroll down and give myself some more room. Give myself a little more room. Oh, that made it that look like an F. There we go. So we can see that it'll be 3 minus 2 plus F minus 1. And we can see that F is equal to 0. So now we can put it into our equation for pi 3. Pi 3 is equal to, so it would be 1 over the density times 1 over the diffusivity, and the diameter is not involved, so it would just be the viscosity divided by density times the diffusivity. Alright, so we have our 3 equations, but we want to relate them. So we can take a look at these equations and see that this is actually the Sherwood number. This is the Pechtel number. And this will be our Schmidt number. And so now we can divide pi 2, the Pechtel number, divide the Pechtel number by the Schmidt number, and we will actually get the Reynolds number. So let me show you. We will do E, divide that by the Schmidt number. Okay. And then the diffusivities cancel out, and then we will rearrange it so it looks nice. It'll be the density times the diameter times the velocity divided by the viscosity, which is equal to the Reynolds number.